I'll start recording as well. Mm.
Okay. So is my screen visible?
Yes, yes, Aakanksha. We can see it.
Okay.
So, good afternoon and all present here. We'll continue with our session. Over to you, Aakanksha.
Okay. So in the last session, we studied about digital image processing, and we did the two parts, which was image restoration and image enhancement. And now we'll move on to image classification. Okay. So, uh, first of all, we should know what is image classification. So, it is basically turning the remote sensing data or with whatever data you have downloaded into meaningful categories, which is represented by different classes based on the spectral patterns or spatial pattern or temporal pattern. So, spectral patterns means if the pic it classifies the pixel based on the patterns of radiance measurement. In spatial, it like categorize based on the neighboring pixel and the pixel's relationship with the neighboring pixel. And in the temporal pattern, it basically provides whatever the changes in the pixel were happened over the time, so that we can detect any feature which appeared or disappeared in the data, so with time. Okay, so there are two types of classification. First one is unsupervised and the second one is supervised classification. So in the supervised classification, it is basically done by computers. So in this one, we don't have to provide any training input or any data set. But in this one, uh, supervised classification, training sets or areas are required, and these training sets you give provide based on your observation. It can be ground-based observation or observe like other observation just by looking at the data. So this supervised classification, I'll show you how to do it. So what happens is in this is that if you see in supervised learning, each training example has a ground truth level. So suppose you go to a area, study area, and you see that in this area there is a lake. In this area there are mountains. So what you do is that you in the software you provide this area as lake and this area as mountain, and based on the provided training set, it categorize the data. So it can be divided into two sets. But in case of unsupervised learning, you don't provide any data. Okay. So what happens is that based on the computer takes these data set and make makes clusters, and based on these cluster it uh, categorize the data sets into different classes. Okay, so this is called as unsupervised, and in supervised you provide the training data, training set. Okay, so this supervised so maybe I can show you one example using dips, like how in the software it is done. So let's see. So if you go here, this is classifier and this is density slicing. So in case of density slicing, what happens is that suppose you have this image. So if you see this, the image is like this, and this is the data view. So each pixel has some numerical value which is called as dn. And what can you do is that you can see in this data what is the smallest number that you, yeah, are able to see? So I think it's 3 for this data, and the largest one is 99, I guess. So 99. So it is starting from 3 going up to 99. So what you can do is that provide slice value. So maybe it will start from 0, go up to 15, then it will start from 15, go up to 30. Okay, so the thing is it's overlapping. So you can just change it. Then 31 to 45, 56 to 60, and 61. Okay. 75, and then 75 to maybe 100. Okay. Done. So if you see, it has divided this data set into these classes based on the value of the pixel. So it is like you are slicing the data into different sets. Okay. So but this is not a better way to do this. What you can do is that you can do supervised classification. Okay, so suppose this is the data and this is image view. You can see some pixels are similar, some are kind of different. So what you can do is that you can just select some data sets that are similar. Okay, and now we will save this signature. Okay, so suppose for me this is water. Okay, so what it is doing is that it is calculating the minimum, maximum. So whatever the training set that I have provided, it is calculating it mathematically. So what is the minimum, what is the maximum, what is mean, what is standard deviation. Okay. Then you will do like do it for some other data sets. Like suppose create new signature and then choose these values. Suppose it is for vegetation, so you can just add this. Now see, it is calculating minimum, maximum, mean and standard deviation. Now you can add some other things like for these, maybe you can save the signature. Okay, so I have divided it into three classifications. So based on the observation, like in this one I have just guessed, uh, but in the software when we will be doing, what we will do is that we will look at the satellite image also and then that image also, and then see which all pixel belong to what thing. Okay, and then we will decide. So there are two different types of classification. So uh, if you see this, the supervised classification can be of different types. One is parallelepiped, and the second one is minimum distance to mean. So in this one, it assumes that the cluster will be in this parallelogram, and this one is simple, this one is precise. So it takes different bands and make some parallelograms, and if the cluster is within that, then it assumes that it will be from the same. Okay, and based on that mean, standard deviation and all, it calculate this. And the second one is minimum distance to mean. So for each cluster it calculates mean for each cluster, and for the training set, if this cluster is with like which cluster is having the minimum distance to the mean of the training input. Okay, so through this, okay, so I think I got disconnected.
Yeah, yeah.
Yeah,
Some network issue.
yeah. So I'm switching off my camera because
Okay,
I'm facing some network issue. So
okay.
hope, yeah. So is my screen visible?
Yes, yes.
Okay. So that's why there are two kinds of classification. This one is MDM, which is minimum distance to mean, and this one is parallel piped. Okay. So we are choosing this one, MDM, and then classify. See, it has classified into three signature because we have only provided three signatures. Okay, now can redo it and do it for the other one. So I will do this in the software. So now you know how how it is done. First of all, we will create give some training set, create signatures, and then like the software will do the calculation, and based on what kind of classification we are trying to do, like which one, minimum distance to mean or this one, it will classify the image. Okay, so now I'll um, try to make land cover map using supervised classification in QGIS. Okay, so I'll open QGIS first. So it's opening. So first of all, we need to add the bands. So I'll go to this data source manager and then raster, and then I'll add the bands. So I'll add band 1, band 2, band 3, band 4, 5, 6, and 7. So for creating LULC, the first step is to make a false color composite. Okay, so for that, what you have to do is that go to semi-automatic classification plugin. So I'll go to plugin and then reinstall it. So now it's there. Now in this one, if you go, this is SCP doc, and in this one you have to go to band set, and then you have to add all the 7 bands. Okay, so now I have added all the bands. Now you have to choose which data is this. So this was Lancet 8 OLI, so I'll choose this one, and then you can create this raster band set. Okay, you have to select a folder. So it will create virtual raster of the band set. Okay, so now what we have to do is that we have to add that. We'll go to raster dataset, and then this one is the stacked raster which was created. So I'll open this and then add. See, now it has been added. Okay, so what I have to do is that I have to make a false color composite. So I'll go to properties, and then this red band will be assigned near IR, so band 5. This green band will be assigned band 4, which is red, and blue band will be band 3. Now apply. Okay, so now I've created a false color composite. Now we can just zoom in so that we can classify the image easily. So if you want better results, what you can do is that apply stretching. Okay, so zoom in and then apply stretch. Okay, so now the features are visible clearly. So now what we have to do is that we have to provide training input like we did in dips. So you can go here and then create a new training input. Okay, so you can save this anywhere. So training input. Okay, now we have to so there must be one option of ROI. So, which I'm not able to see right now. Okay. So I'll go here and check. So we have to zoom in before selecting. Okay, so I've created one polygon. So this is just for choosing the color. So I'll just remove this. So this I have added ROI polygon. Now I have to add this. So so maybe I'll start from the beginning. I think there is some problem. Okay. Yeah. So first we need to add the layers. Now I have to create an FCC. So for that we need this plugin. So now this doc is here. So what I need to do is that add the bands, all the 7 bands. Okay, then this and then this. So okay, so I've selected the folder and now I need to add that. Or maybe I can check if it's there or not. So no, it's not there. So I'll just add that band. So this is the virtual raster. Okay, so now it's added. Maybe I can remove these. Layers. So now I've removed. Now I will create FCC. Band 5, band 4, band 3. Now apply. Now we can just zoom in that area and then do a contrast stretch. Okay, so that this appears clear. Now we have to go to this SCP doc. And go to this training input. And then we have to create a new training input. So you can go here and then okay. So now what we have to do is that add ROI polygon. So maybe I can remove this one, or this is the option. of ROI polygon, and now I can just zoom in. So okay, the thing is like I removed those sets, that's why it's not appearing here. So maybe I'll just first do it for ArcGIS and then come back to do it for QGIS. Because right now it's confusing. So in this one, first we need to add all the bands. So these are the bands. B1, B2, B3, B4, B5, B6 and B7. Okay, so now I've added all the bands. Now what I have to do is that make a false color composite. So for that I have to, I can just go here, search and then composite, and then composite bands. You have to provide input raster. So I'm adding all the bands, and output will be somewhere here. Okay, so it will create that FCC. I think it will take time. Now it has created FCC. So I just have to change these bands. Apply. And now I can zoom in the area. Yeah. And then I can also apply stretch. Okay. So now it's clear. Now what we can do is that make a shapefile here to extract only this area, and then we can do LULC mapping. So for creating a shapefile, you can just go here. Okay. Go to any one file. And then right click new and then shapefile. Okay, so you can name this. So this is our study area, and then choose polygon and then OK. Now what you can do is that go to editor, start editing, choose this study area, continue, and then you can go here and create features. Choose this and then polygon. So now what you can do is that to choose this study area, then right click and finish sketch. Now you can go to this, save edits and stop editing. Okay, so now what we have done is that we have created a shapefile. Now what we need to do is that extract the feature. So for that you can go to search and then extract by mask. Okay, so you can see here, double click on this extract by mask, and then you can provide input raster. So it will be this one, and then OK. So now it is extracting we have to wait. Okay, now it has been extracted. Now again for this I'm creating FCC, so you can see, and now I think the features are clearly visible. So now what we have to do is that we have to do image classification. So for that you have to right click in the main panel and click on this image classification. So for my case it's already on, so I'll just show you how to do it. Just right click and then go to this image classification. Now this toolbox has been added. So in this one you have to open training sample manager. So this is training sample manager. Okay, so you can see this is the manager. So whatever you will add will appear in this one. Okay, now you have to draw polygon. You can see this option, draw polygon. Now you have to click on this and then zoom in. So draw polygon. So this area is water. Now I'll draw another polygon from other areas. Okay, so draw polygon. So this is also water. Now go to other parts. This is also water. So I'll just draw polygon. So it's good to have um, different polygons in different parts so that your data is not biased. And now what you can do is that you can choose these three and then merge it. Now it is, you can change the color. So for water I'll choose this color. Okay, now similarly you can do like zoom to this layer and draw other polygons and merge them if they are from the same class. Okay, so now I'll go to this area. It has some snow, so I'll just go and draw polygon. So what it is doing is that taking the pixels which are there in this polygon and then calculating mean and standard deviation, minimum, maximum. So whatever that was happening in that dips. Okay, so you can choose these from different areas. Okay, so now I have added these. Now I'll merge them, and this is snow. You can also change the class name. So this is water, this is snow. Now I have to choose other training sets. So like we have applied FCC and The red areas are the vegetation. So these are the parts which are covered by vegetation because vegetation reflects uh, light in near IR, and near IR is assigned a color of red. So that's why the areas which are appearing red are the areas which have vegetation. Okay, so those you can classify as vegetation. So just select this. Now this for vegetation you can assign a green color. Let's say it's vegetation. So this is supervised because we are providing all the training sets, and the computer is calculating the mean and the standard, like it is doing statistical analysis of the data sets that we are providing. Okay, now maybe I'll just add, so these may be bare soil, so I'll just add this as okay, bare soil. So for this classification, what you can do is that you can maybe add a base map and see what is there. So I'll just show you. So it is adding a base map, so it is kind of a satellite image, and you can see what features are there in satellite image. So and then you can classify that this area was snow, this was this. See, so this is the area which I am adding, and it looks like it is bare soil only. So what I can do is that just add this, merge them together, and then write bare soil. So for providing training sets, maybe you can use the satellite image or any information that is there in the literature, or you can use like if you have been to this study site, you can use the information that you gathered there. So these things you can do. Okay, so now we have these four training sets. Now what we have to do is that go to this classification, and then we can choose which kind of classification we want to do. Okay, so before that we need to save this signature. Okay, so this has taken these signatures, and then we can save this. Okay, so I'll save it as signature. Okay, and then save it. So it has this signature file. Now we can go to classification and then choose this maximum likelihood classification. Okay, now you can choose the input raster band. So I'll choose this extract. Okay, so and then this input signature file is needed. So this we saved in this data and then this signature. So you can just open it and then okay. Okay, there is some error. So maybe I'll do it one more time. Okay, first we need to choose the classification types. So I have chosen maximum likelihood classification. Then I have to choose this. Okay, so okay, and then signature file. Pen, and then we need to choose the output. Okay, so in this one only I can save. Then okay. So I don't know why there is this error. So this was saved, then classification, and then output classified raster empty. Okay, I got it. So this classification we did for this one, B1. So that's why it was not working. Okay, so in this one we have to choose the extract and then draw the polygon. So maybe I'll do it for this B1 only and then see if it's working or not. Okay, so that's why it was there. Okay, then input, then okay. Yeah, so I think now it's done. So the thing is, now you know what was the problem. In this one, it selected this one, band 1, but I thought I'm doing it for the extract, and then when I was doing it for the extract, it was not coming. So whatever you choose here for classification, it will classify that only. Okay, so I'll go to this one and then change the symbology. So this one was water, snow, and then bare soil. So, but the thing is, we didn't classify it in many classes, so that's why like lots of these are appearing to be water, but it's not. So, the more the training set is and the more the classes are, the better is the classification. Okay, and always remember to check this thing because I missed it and you had to watch me repeat all those steps. Okay, so this is how we can classify this. Now, what I can show you is that if suppose I have this map in that I have classified land cover, land uses, and it's correct, and there are many classes. Now, if you want to know what is the area of that particular, so what is the percentage of water in that area, what is the area that is covered by vegetation, so this area thing also you can calculate. So what you have to do is that you have to uh, convert this raster into polygon. Maybe I can remove this, go to search and then raster to polygon. Okay, so it's here, raster to polygon conversion tool. Now you have to this and then okay. So now it is converting this raster to polygon. So if you look here, it has this object ID value and count. Okay, once it is creating, we have to wait for some time. So because this is not the clipped area, it is taking a long time for conversion. But if you clip this area, then it will be fast and it will give a better result. Okay, so now if you see, so see these polygons have been created. Now what you can do is that go to the attribute table. So right click on this, then open attribute table, and then you can see in that one there were only three columns. Now you have shape, ID, grid code, shape length, and shape area. And from here you can see, like if you click on this shape area, it's already given. So this grid code one was what? Water. So water area is this according to this. And then grid code 4 was snow. So this area is covered by snow. So this you can use for knowing what was the area covered by this. Okay. So this is how you make land use land cover map. So the important thing is that you have to make as many classes as you can, and it is based on whatever you have observed in that area. So if you have visited that area, or you can use satellite map for more accurate classification. Okay, and you have to provide as many as polygons for one training set, uh, and choose it from different areas so that they are not biased. And while classification you have to take care of this. I forgot this and I ran into error. Okay, so this is how you do this in ArcGIS. Now I will show how to do it in QGIS. So I hope this time it will not give any error. So one more thing I wanted to show you, that if you use this link, then you can have land use land cover map without doing any of these analysis. So this is ESRI Sentinel 2 Land Cover Explorer. So you see, if you go here, you can see this built is, so buildings are red, water is this, trees are this. So from here, for any desired area, you can download the map. So you can see crops. So these yellow ones are the crops. If you click this, it will show, and you can have the data starting from 2017 going up to 2022. So for these years you can download land use land cover uh, maps. Okay, so you just have to go here, and then you can download for whatever area and whatever rectangle you want to choose. Okay, so this is just to show you, like using this also you can, like they have already classified. So for whatever area you are classifying, you can go to this site and just see what all classes are there, and then apply it to your classification. Okay, so that's why it's helpful. So maybe when you will be trying to classify, you can use this one. Okay, so first I'll add all the bands. So I think if I'm repeating these, how to create FCC, then I think this will be clear. I don't know if I'll be able to do LULC or not. So B1, B2, then B3, B4, B5, B6, and then B7. So these all bands I have added. Close. Now I have to go to that plugin, then reinstall it. There is one more way to do it. So you can just go to this semi-automatic classification plugin and then add the band sets. Okay, so select all these and then OK, then this, and then run, and Control Z. Okay, so I have to select folder. Okay, so now it has been added. Now I can just go to training input and then first I need to add that band. This is the one. Maybe I'll keep this here. Okay, and then this one here, this one will be here. Okay, so now I think it's not here yet. Okay, you can go to properties and then change this. And then zoom into that area. Okay, so now we have to create this signature, and then I have to add polygon. So this one was water. So I have to edit this. MC ID and class ID, and then save the signature. So now it's there. Now I'll just add, so this time I'll only add one polygon for different kind of classes, but for good classification you need to add as many polygon as you can. So from this area maybe I can add snow. So go here, polygon, and then just add, and then so in this one this is snow, anything. So this, okay, snow, and then add this signature, and then you can change the color if you want. Okay, now you can add other things also. So this is how you do, like what you are doing is that you are adding the training sets. Okay, and then maybe I'll add two more training sets. So these are mountain areas. So okay, so save. Maybe I'll add one more, which will be from vegetation. Okay, so so these red ones are covered by vegetation, so I can add that one. Okay, so and this one is plants, anything you can write, and then it has classified. Make it, maybe I'll add the color. Okay, so this, these all signatures we have uh, added, and I have divided it into four different types. Okay, four classes. Okay, Now what we have to do is that we have to go to band processing. Okay, so you can go to band processing, click this, and then classification. And in this one you can use macro class ID or class ID. Okay, and then you can, so Z score, this one is okay, and then you can just run. So maybe I'll save this. So I think it's processing. So the algorithm that it is using is maximum likelihood. Okay, so it is still processing. It will take some time. 60% done. So now it's done. So if you see this one, it has divided it into 4 parts based on class ID. So the blue ones are lakes, the white ones are ice. So the more the classes you add, better will be the classification. So that's why you have to use, you can use this sites data, like how many classes they have divided, what all classes they are giving, and you can use satellite data. And if you have been to um, that study site, you can use the observation that you recorded there. Okay, so this is how you can do this. Now if you want to do this, calculate the area in ArcGIS, you have to go to raster and then conversion, and then you have to polygonize. So make it raster to vector. Okay, so run it. So the thing is, if you want to calculate the area, you have to convert the raster image to the vector image. So that's why I am converting this LULC to vector. Okay, so it's 75% done. So as I didn't clip the area, so what you can do is that you can clip the particular study area and then do this analysis, so then it will not take this much of time. Okay, so I have to wait. So I'll just tell you what all I'll cover after this part. Okay, so as we know how to create this LULC, now suppose you have one study area and you want to create a shapefile and do some interpolations. Say, suppose you have some observation from a study area and you want to plot it. So I'll show you how to plot those uh, in ArcGIS and QGIS. Okay, so it's 75% done. So I'll just open ArcGIS and show you how to create shapefile. So I think this making shapefile I already told you, but I'll tell you right now. So yeah, uh, if you see it's complete now, maybe I'll just finish this one. So now it has been converted to polygon. Now what you can do is that go to processing toolbox and then search value. So you can use this raster layer unique values report. Okay, so use this and then run this. Okay, so if you see this one, you can see for value 1, so value 1 was water, I guess. So for that the area is this in squared meters. So from this you can know what was the area, percentage of area for which kind of classification. Okay, so this is how you can classify this and then calculate the area. Okay, so now I'll just close this. Okay, go to ArcGIS and then show you how to make a shapefile. So suppose my study area is Ruler Lake, which is in Jammu and Kashmir. So what you can do is that you can add one base map. Suppose this is the base map. So it's loading. And now you can zoom in your area of interest. Okay, or any feature you can just. So this is the lake. Now what you have to do is that first you have to check the coordinates. So which coordinate system it is taking. Okay, so go to layers and then properties, and then you can see this is WGS 1984. Okay, and apply. Okay, now what you can do is that go to this catalog and then go to any of these. So suppose this India boundary, then you can right click new and then shapefile. Now you have to create a polygon and then study area, then OK. So and then go to this editor, start editing, and then choose this, continue. Now you have to go to create features, then study area, and then polygon. Now what you can do is that you can just select the area. So you can do it precisely when you will do. I'll just do it faster. Okay. Suppose this is the lake which I have studied. Now right click, finish sketch, and then you have to save edits and then stop editing. Now it has created one shape file which is showing this lake. Okay. Now suppose you have data sets for these and this lake, then what you can do is that what I'll do is that add one shapefile that is accurately presenting this study area. So I'll just add that. So maybe okay. Okay. uh, Now what we want to do is that suppose we have some observations from different parts of these lakes. So maybe I'll show you the data set uh, so that you can imagine. So I'll just go here, interpolation, and then data. Suppose this is the data set that we have, and if you see, it has sample code, then latitude value, longitude value, and then suppose the property that we observed is sand percent. So here you can see for different latitude and longitude we have sand percent. So what you want to do is that we want to add those data sets and then interpolate it throughout this lake so that we can understand which part of this lake is having higher sand percent and which part of this lake is having lower sand percent. Okay, so for that what you have to do is that you can just go to file and then add xy data. Okay, and here you can go, okay, and then add this data, latitude, longitude, and in the z field you have to add the one which you want to interpolate. So in this case it was sand percent, so I'll choose sand percent. Okay, and then click OK. So it is adding the data. Okay, see, these were the points which were measured. Okay, so from like observation we know these points have this much amount of sand percent. But the thing that we want to do is that we want to interpolate this such that all the areas of this lake has some value. So we can do IDW, which is uh, inverse distance weighted interpolation. Okay, so based on the inverse distance, it interpolates the data. Okay, so for that, what you have to do is that you have to go to Arc Toolbox. Then you have to go to Spatial Analyst tool. So I think it's here, Spatial Analyst tool, and then you can go to Interpolation and then do IDW. Okay, so you can add input point features. So this was the sheet 1. Z field will be sand percent. Okay, and then go to environments. Now you have to define the processing extent. So the processing extent will be same as the this Shapefile, which is Buller Lake water. Okay, and now you have to go to this raster analysis and then mask this Buller Lake water. Okay, and then click OK, then OK. So it takes time. Oh no. So there is some error. Output raster image. Okay, okay. So I'll just try one more time. So input feature will be this events. Z field will be. So while adding, which was the, we added sand percent, right? So let me add one more time. File, add data, add XY data, and then this sheet. Okay, and then Z will be sand percent, and okay. Now I have added IDW this, and the Z field will be sand percent. Okay, uh, so the thing is my that one drive is full, so that might be problematic for saving this file. So we'll go to this interpolation, then okay, and name will be IDW. Okay, go to environments and processing extent, and then raster analysis. So mask this now. Okay, I think now it should do. So the thing is, this one is full, so that's why it's not saving anything. So that's why I had to change the directory. Okay, so now if you see this one, you can see it has classified it. Now what you can do is that if you want to change the properties like the way it looks, what you can do is that you can just go here, stretched, and then choose any of these, then apply. Okay, so now you see the higher values are denoted by this color. So these are the points where the sand percent was higher, and these are the points where it was lower. Okay, so that's how you can interpolate the data. And then if you want to save this image, you can just like add few things, like for decoration purpose, insert north arrow. Okay, you can insert north arrow, then you can add legend also through this, and you can also add coordinates. Okay, so you have to go to properties and then coordinate system, no, grids, and then apply. Oh, I don't know why it's okay. Properties, apply, and then go to properties, then interval should be less. Okay, so you can choose it to be okay, and then apply it, so it should come. So I think this I have to decrease. So the interval is high so that it is not coming here. So 5. I don't know why it is not coming. So this is how you can add. I'll just tell you later. Okay. So this is how you can create spatial interpolation IDW plot using ArcGIS. Now I'll show you how to do it using QGIS. Okay. So for that you have to go to layer and then create layer, and then you can go to new shape file. So layer, create layer, and then new shapefile layer. So here you can give the file name, so study area, then you can, okay, the coordinate system is here, so you don't have to worry. And maybe I can choose this one. Okay, and then geometry type, it will be polygon. Okay, so now you can click OK. So now if you see this part layer, this one has been added. Now what you can do is that enable editing. So you have to go here. Okay, and then it has enabled editing. Now what you can do is that mm, add polygon. So I have to go to this one. So first I'll check the properties if there is this coordinate system or not. So it's there. So changing order is not okay. Okay. Apply. Then okay. And then what you can do is that you can like enable editing and then add polygon feature. So you can choose features. So first you have to like you can what you can do is that you can so I'll this is optional. So what you can do is that you can first add the base map and then draw the feature. So I think I don't have much time, so I'll just do this and then add that layer which I did earlier. So I'll add. So if you want to add any shape file, you have to go to vector because shape files are vector layers. Okay, so I'll just go here and then where is that shape file is here? So I'll just open it, add it and close it. So now I think it has been added. So I'll just zoom in to the layer. Okay, so you can change the fill and choose this or anything. Okay, any color you can choose. Okay, now the thing is I don't want any color. You can do this. Okay, now what you can do is that now what you have to do create IDW for this. Okay, so now we have created a shapefile. Now we'll do spatial interpolation. So for that you have to go to okay, yeah, you have to go to layer and then add layer and then add delimited text layer, and here you have to choose the file. So for this kind of like in QGIS you need to have CSV file, so it takes CSV file. So you can see this is CSV file. Okay, so see text file, CSV file, these kind of files it will take. So that's why I have created CSV file for this. Okay. So now add, then close. Okay. So as I have added this CSV file, now I have to go to toolbox. Okay. So first of all, I'll go to, this is processing, then toolbox, and then you can search for raster interpolation. Sorry, raster interpolation. So raster is here. So I'll just search interpolation. Okay, it is not coming here. So maybe what I can do is that hmm, go to the main panel and then see. So maybe I can go to raster and then I don't know where is that interpolation. So it should come here. Interpolation. Yeah, it's there. Interpolation. Okay. So IDW interpolation, and then interpolation attribute will be sand%. Okay. And then you can just run this. Okay. Wrong or missing. Okay. So I'll just, so vector layer will be, okay, so the vector layer will be this Fuller Lake, water, and then interpolation attribute will be, okay, now I can, so I don't know why it is not coming. So sand%, and then this will be, Okay, and this one I can remove. Now run. Still not coming. Okay, I need extend. So it will be calculate from here. So now I think it should come. Yeah. So I don't know where it is. So maybe I'll do it one more time. IDW, then sand percent. This vector layer will be this. Then pixel size I have to decrease because you see there were only 3 pixels. So this in this one you have to decrease the pixel size, and then extent you have to provide, so you can calculate from layer and go to Wooler Lake water and then run. I think now it will be better. Okay, so oh, so I think it, so you have to mask your area from this in this one. Okay, so you can just change it and then apply this. Okay, so what you can do is that you can mask your, like, clip your area of interest and do this. Okay, so this is how this IDW interpolation is done in this one. Now yes, discard. Now you know how to interpolate. So now I'll tell you how to download DEM data and then plot it in and calculate the slope in ArcGIS and QGIS. Okay, so this is the site from which you can download Cartosat 1 DEM data. So I'll just show you how to do it. Just search it and then you can choose Cartosat 1 product all versions. Okay, now you can go to tiles and then start. Then you can choose any tile of your interest. Okay, then stop and then next. So now you will get different versions of that data, and one of them you can download. So I have already downloaded DEM data for one area, so that is the same area I guess. And from that one what I'll do is that I'll uh, calculate the slope and how to do it in ArcGIS and QGIS, that I'll tell you. Okay, so now one more thing that you need to know is that why we are using Cartosat 1 data for calculating DEM. So the thing is, the Cartosat data has spatial resolution of 2.5 meters. Radiometric resolution is also good. It is 10, and it carries two stereo pairs. So it has two cameras which are at different viewing angles. So because of this slight parallax shift, what happens is that you can calculate the elevation and create digital elevation models. Okay, so that's why I have downloaded this Cartosat 1 data, because it contains uh, this information about elevation. Okay, so now I'll tell you how to do it in ArcGIS. So you have to open ArcMap. Okay, so I'll just keep this search one here. Okay, now you have to add that DEM data. Okay, so you can just add that folder. So this was the one. Okay, DEM, this one. So this is the data, you can see. So the elevation is starting from uh, 1499 and going up to 4339. So it is from Srinagar and neighboring areas, so that's why elevation is high. It's from Jammu and Kashmir. And now what you have to do is that you have to first check the coordinates. So which coordinate system is this? So you can go to source and then check the coordinates. So it is GCS, that means geographic coordinate system. So first we need to convert it into projected coordinate system. Okay, so for that you can just search project raster. Okay, and then search, and then click on it. Add this input file. Okay, name will be anything. So projected DEM, and then okay. Okay, I have to choose output coordinate system. So for this we will go to projected coordinate system, then UTM, and then WGS 1984, then Northern Hemisphere, and then you can go to 42 North, that is for India, and then okay, okay, and then click OK. So now it will project this, so it should come somewhere here. Yeah, so now it has been projected. Now what we can do is that make contours from this. Okay, so you can just search CONTOUR contours. Okay, go to this, then input will be this projected one. And contour interval you can give any number, 80, okay, and then okay. So now it will create contour. Now we will convert this to, now it is loading. So if you see this one, these are the contours that it has created. Okay, so based on the elevation, it has created contour lines. Now you can go to this create 10 and then I have to change the output because that one is full. So 10 coordinate system is optional, but still I will give it UTM 84 Northern Hemisphere and then 42. Okay. Now input feature class this. Okay. So now it will create 10 and that we will convert into raster and then classify it. So for that you can search 10 to raster. First we have to wait. So now it has created this 10. So you can see based on the elevation it has classified it into different classes and now it is creating these triangles, pyramid like structures. Okay, so now we have to convert this 10 to raster. Okay, so it will take time to load. Input 10 will be this, output will be that I have to change. Okay, what will be the name? So raster DEM. Okay, output type will be float and then okay. So now what it is doing is that converting this tin to a raster and then from that we will calculate the slope. So that has been done. Now we will convert calculate the slope. You can go to slope, spatial analyst tool and then provide this raster because this only uses raster, that's why we had to convert it into raster. Okay, then output raster we have to provide, so I think it's in So this will be slope and then save and then OK. So if you go to this one, this is based on the degrees. So 0 to 2.7 degrees and it is going up to 49.93 this degree. Okay, so this is the slope that is there. Now you can go to properties and then change it if you want the classification, or you can just keep it like this. And then if you want to calculate the area also, then what you can do is that you have to reclassify this, reclassify, and then add this slope. Now you can see it is just providing this, so you can either change these values like 0 to 30 degrees, give the value 1, or you can just keep it like this. Just remember this thing. So, and also you can change this output raster. So now it is classified. Okay, okay. So it is reclassifying this. So now you can see it has classified it into 9 classes. Now what we can do is that we can just convert it to polygon and then calculate the area as we did for LULC. Okay, so raster to polygon. So you can use this classified and then okay, polygon, then okay. So where is that polygon? Oh, now you can go to attribute table. So as the values are very large, so it is taking long time. Okay, so you see there are different grid codes, so they are starting from 0 to 9, so maybe you can sort it. Or right click, or you can go to select by attributes and then type grid code is equal to, select grid code is equal to, and then provide the ID 1. So what it will do is that whichever is having, like, you can see grid codes are repeating, so it will merge this. Okay, so for merging you can go here, start editing. You have to edit this classified, no, polygon DM, and then continue, and then you can apply here, and then what it will do is that go to editor and then merge. So what it will do is that it will add merge all the polygons that are having grid code of 1. Okay, so similarly you can merge this and then just add. Okay, so you can merge so that you only be having 9 grid codes and 9 IDs. And then what you can do is that um, go to go here and then you can add area. Okay, so where is that option? So you can go. You can just click here. So I think this I have to close first, stop editing, and then yes. Now you can just there should be one option to add area. Okay, yeah. So add field and then area. Then it will be float type and okay. So now it has been added. So here you can go. So now it will add area. So it is taking time, I guess. So what I can do is that I can tell you these steps in QGIS till it loads or calculates the area. Okay, so I'll just start QGIS. Okay, and then you have to import the data. So you can go here, cartoset data. I think it is in delimited, so that's why it's not coming. Go to raster and then add this data, if file, open, add, then close. So now it has been added. Now first you have to go to projection, so raster projection, and then wrap. So run this. So it has been reprojected. Now you have to go to raster again, then analysis, and then you can calculate slope. So in this one, you don't have to do much for calculating slope, but in ArcGIS there were so many steps, so 10 and then other things. So what you can do is that you have to compute edges also, and then you can run. So if you see here, you can see this slope. Now you have to go here, processing toolbox, and then you can reclassify it. Reclassify by table. Okay, so it should take the slope and then run. Okay, so first I have to provide some parameters. So in this one I can add rows, so maybe minimum 0, then going up to 30, value will be 1, then 30, 60, and then 2, and then 60, 90, and then 3. Okay, so now you have provided the parameters. Now you can run it, close. Okay, so you can see, you can just go here and change the appearance. So, and you can, oh, so it should be, so there are 4 levels. Okay, so you can just apply this. Okay, so you can see, so the slope is above 60 in most of the cases, so that's why it's appearing blue. Now if I zoom in to some areas, you can see the differences. So maybe you can have more classification so that you can get more detailed uh, idea about slope. Okay, now you can just enter raster layer unique values report. Okay, so in this one you can put this and then run, and now if you just go here, you can just see this area count. Okay, so uh, the slope, you remember the value, so the slope which is from 0, starting from 0 and going up to 30 is having this much area, and this is having this much area. So this is how you can do it in QGIS. Okay, so that was all. So I think in this session I was running into errors. but finally I was able to get it. Okay, so thank you.
Yeah, Akansha.
Yeah, yeah, yeah. So, so this time I
Done.
was like, yeah, I'm done. So this time I
Yeah,
was
okay.
like running into more error because there were lots of steps, but
Okay.
yeah, luckily I got it. So all the
Fine.
links and everything, I will share the slides with you so that
Sure, sure.
yeah, students can go through it. And
Yeah, okay.
I think now I
Mm-hmm.
can turn on my video. So I was having some network issue also. So the thing is,
Mm-hmm.
most of the time, what was happening is that uh, like I was saving those files into a file which was like into one folder which was like completely uh, full. So that's why it was
Mm-hmm.
not saving it. So I realized when I went here, and you can see this, or no, I'm not sharing my screen, but if I share you, I can show you. So what was happening is that I was sharing all the file, like saving all the files here, and
Mm.
it is now completely full. So it is not taking any file now. You can see?
Okay. Yeah,
Yeah.
yeah, yeah.
So
Okay.
this was happening. So I was not able to realize it, like why it is happening. And later on, I realized. So every time I had to like change the output file location.
Fine.
Yeah.
Okay.
Yeah.
Anyways, we were able to sort the issue now.
Yeah. 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 So,
Yeah.
like if students will have any doubt, they can ask
Mm. Yeah,
later on
sure.
also. Yeah.
Yeah, sure. Mm-hmm.
Yeah.
I'll
So,
share the PPTs and materials that you are going to share with me. I'll share it with the students as well.
yeah. Yeah. Yeah.
Mm,
Sure. Sure.
yeah. Yeah. Students, do you have any doubt? The session is open for queries. If you have any, you can just ask it with Ms. Akanksha. Anyone? Anyways, if you have any doubts in future as well, you can just ask it. She'll be
Yeah. Yeah.
responding your queries. Yeah.
Yeah. Yeah. Yeah.
Yeah.
Okay.
Okay. So thank you so much.
Yeah.
It was a good hands-on sessions. Maybe it will be useful for students when they are using it for their projects.
Yeah, 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 sure. Because the thing is,
Yeah.
just by watching it's difficult. But the
Yeah,
thing
yeah.
is,
If they are
like,
doing it, they are wetting their hands and doing it, they'll be really getting the thing there.
yeah,
And
yeah,
that time
yeah.
they'll be facing so much of errors and
Yeah,
that
so I
requires
was
your help.
also facing this today only.
Yes.
So,
Okay.
yeah, yeah, yeah.
Well,
Okay.
I think we'll wind up. It's also time. Yeah.
Yeah, okay,
So
okay. So, thank you, everyone.
thank
Thank you, ma'am,
thank you so much.
for
Thank
this
you. Thank you so
opportunity.
much.
Yeah, yeah,
Yeah.
yeah.
Thank you, Akansha.
Okay, okay.
I'm just
Okay,
giving in meeting to end. Yeah.
okay, okay. Bye.
Thank you. Bye bye.